Welcome back to Introduction to Software Reverse Engineering. In this module, we will explore unions in C and the ways in which it is possible to reverse engineer the code that uses unions using Ghidra. Get ready for a lot of practical work today. Welcome to Module 13. In this module, we will examine unions and the impact they have on reverse engineering the code that employs unions in its data structures. Let's start. In this module, I want to examine unions in C and how to work with them in Ghidra. Unions can be widely used. For example, there is a lot of union use in DirectDraw, Direct3D8, and Direct3D9 APIs, where unions are used to reduce the bloat and size of the structures that are passed from programs to these APIs and back. All materials covered in this course are available on GitHub. The link is shown on the screen and is available in the description below the video. In C programming, a union is a user-defined data type that enables storing different data types of data in the same memory location. This allows for efficient memory use, particularly in environments with limited resources, such as embedded systems. A union's key characteristic is that only one member can be utilized at a time. Assigning a new value to a different member overrides the previous value. The primary benefits of unions are memory efficiency and flexibility. By reusing memory space for different data types, unions can reduce memory usage. This makes them suitable for applications where memory conservation is crucial. Unions can be applied in situations where a single variable needs to hold different data types, such as integers, floats, or character strings. By utilizing unions, developers can optimize memory usage and streamline their code. When deciding between structures and unions in C, it is essential to consider the specific requirements of your application. If you need to store multiple values simultaneously, a structure is a better choice. Structures allocate memory for each member, allowing you to access all members at the same time. On the other hand, if memory efficiency is critical and you need to store different types of data in the same memory location, a union is more suitable. Unions allocate memory based on the size of the largest member, making them ideal for applications where memory conservation is crucial. However, this comes with the limitation that only one member can be accessed at a time. Fire up Ghidra in import unions.exe example application. Make sure you auto-analyze the program when prompted in the code browser window. The default settings will do just fine. In this module, we will not look at the source code at all, and will jump into reverse engineering right away. The source code is available on GitHub anyway. The link is in the video's description. The function of interest is shown on the screen. It has a few interesting elements. First, there is a function that is very likely to be a printf function. See lines 7, 11, and 15. Change the function signature to match that of a printf. Once the printf function's signature is corrected, the compiled code will slightly change, which is the desired outcome. Now, another interesting part of this function is the local 8 array of 2 integers. The interesting aspect to it is that the value assigned to it on line 14 looks like a floating point number and not an integer. And third element of interest in this function is the calls of the same function on lines 11 and 15, which returns a formatted string value to be printed out on lines 12 and 16 respectively. Let's take a look at the formatting function. The value formatting function is shown on the screen. See how Ghidra applied a pointer to an integer as the parameter data type. One of the reasons for such type detection is on lines 7 and below in the code, where the value is compared to integers. Given that Ghidra doesn't know the real type of the parameter, this is something to work with. Now, another interesting part of this function is the highlighted variable is being used so many times and in different contexts. One context as the first argument of the function call, and also as a return value for most control paths. Let's look at the second arguments for the same function calls. These values contain a format string that can be used in a printf function. That's good to know. Now, let's inspect the function that accepts these values as parameters. This function is interesting. First, note how Ghidra assigned types to the parameters, pointers to undefined 1 and byte, which in this situation is essentially the same, 1 byte long data types. Second, the already seen in the previous modules stack automatic variable for variadic parameters. Given that this function formats the string based on the format string and a variable number of arguments, and populates the buffer passed as the first parameter, it is rather safe to call this function as printf. Change the signature of the function to match that of sprintf as shown on the screen. Now, let's go back to the previous function. With the sprintf signature applied to the codebase, this function transformed, but not fully. See that the sprintf function calls are still missing parameters. Ghidra's behavior is inconsistent here. Let's fix the sprintf function call on line 9 together in this module. I will leave it to you to practice independently on a sprintf function call on line 19. First, change the data type of the format string to a string, as shown on the screen. The HD format string should appear, indicating a short integer as the expected value. This is an important clue toward reverse engineering the union used here. See that the other format strings are indicating use of a single precision floating point value and an integer, lines 16 and 19 respectively. Let's override the sprintf function signature so that Ghidra is aware of the missing argument. Right-click on the function's name on line 9 and select Override Signature in the context menu. The Override Signature window will appear on the screen. Add another parameter with short as the data type and click OK to apply the change. Once the change is applied, the sprintf function on line 9 shows all of its parameters. Now, let's create a new union data type in Ghidra to capture the variety of data types that we discovered together in this function. Right-click on unions.exe in the Data Type Manager window and select New Union in the context menu. The Union Editor window will appear on the screen. In the Union Editor window, add 3 known data types, a short, an integer, and a float. Also, change the name of the union from the default name to Custom Union. Don't forget to save the changes before closing the window. Now, let's create a structure. It would allow us to distinguish the type of the value stored in the union. This is so-called tagged union. See that the code checks the first member of the input parameter to determine the type of the second, lines 8, 12, and 13. To create a new structure to represent this tagged union, right-click on unions.exe in the Data Type Manager window and select New Structure in the context menu. The Structure Editor window will appear on the screen. Rename the structure into Custom Struct and add the members to the structure definition as shown on the screen. Don't forget to save the changes before closing the window. Now, let's change the function signature so that it accepts not a pointer to an integer as a parameter, but a pointer to a newly created structure. Change the function signature so that it matches the signature shown on the screen. Click OK to apply the changes. Once the new data type was applied to the function's parameter, the compiled function now properly shows the data type of the passed-in value and is properly using the value itself. Now, let's go back to the caller function and see how the new data type for the function parameter affected it. The proper data type changed this function drastically. It looks extremely close to the original source code, except line 14. Ghidra is pretty bad when it comes to unions, so it is on you as a reverse engineer to make sense of the code at the end of the day. Also, note that line 10 has assignment of the integer member of the union, and not the short member. It is the same behavior as we just discussed regarding assignment on line 14. One last thing for this module. Ghidra supports creation and using enums, or enumerations, like other types. You can create one by right-clicking on the program or library in the Data Type Manager window and selecting New Enum in the context menu. The Enum Editor window will appear on the screen where you can add members of the enumeration and the values assigned to them. I will leave it to you to create one and modify the structure we created earlier to use the enumeration, and see how it works in tandem with the union. In this module, we reverse engineered a new example program that showcased use of unions and picked into enumerations. In the next module, we will take a closer look at and examine bitwise operations, which are very common operations when working with various flags. See you in the next video. If you are looking to dive deeper into software reverse engineering, I'd like to recommend my book, Software Reverse Engineering: Navigating x86 Windows Applications with Ghidra. This course draws heavily from the book's content. However, the book itself contains many more examples and insights that can help developing your reverse engineering skills. The book is available in both print and digital Kindle versions on Amazon, making it easy to access and read wherever you are. Additionally, the book covers subjects not discussed in this course, such as reverse engineering of C++ programs, classes, virtual functions, and more. I encourage you to check it out. Thank you so much for watching and learning with me today. If you found this video helpful, please hit that like button and subscribe for more content like this. Your support means a lot to me. If you have any questions or topic you'd like to discuss, leave a comment below or shoot me an email. I'm happy to chat. If you'd like to support me and the channel financially, you can do so through Ko-fi or Patreon. Links are in the description below. Thanks again for watching, and I will see you in the next video.